Hey everybody, welcome to Parametric Equations. Nicholas JMV here. So what we're going to go ahead and do is do a couple more examples of parametric equations, how to graph them, and how to eliminate the parameter. Okay, so let's redefine or define again. A parametric equation is simply an equation for a curve given by specifying x and y as functions of a third variable called a parameter. And they're usually written as x is equal to f of t and g, or y is equal to g of t. Okay, so let's look at two examples with this definition in mind. So what we're going to do is we're going to go ahead and graph the curve specified by the parametric equations. X equals 1 minus t and y equals 2t plus 2. And we're going to go ahead and do this two different ways. Okay, now one way to do it is to create a table of values. I'm going to go ahead and do that. And you start by really just taking your t, okay, and then we're going to draw a little bit here. You're going to have x, which I'm going to put 1 minus t, and you can leave some space so you can work these out. Y equals 2t plus 2, and then your ordered pairs x and y. Okay, so you can do it that way. This way is longer, okay, but it gets the job done. I can pick some t values, okay. Now, depending on if it's all real numbers or if you're dealing with time, but it's not specified here, so I can use any value here I want to. So I'm going to go just 0, 1, 2, okay, even if you want to do 3. So you're plugging all these t values in here and here to find out what x and y are. So you're no longer given a specific number for x and y, you have to work for it. So I plug 0 in here, so 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 2 is negative 1, and 1 minus 3 is negative 2. Okay, so I could go ahead and theoretically start putting these ordered pairs together, 1, 0, negative 1, negative 2, and you might want to do that because you might screw up and accidentally put t over here, which is common. Now all these t values go in for t here, so 2 times 0 plus 2, so that's 2, right? And 2 times 1 plus 2, so 2 plus 2 is 4. Plug in 2 now, 2 times 2 plus 2, that's 6, so you can see the pattern 2, 4, 6, this one will be 8. And now what we can do is you can go ahead and graph this if you wanted to. I can go ahead right here and just graph what I have. Okay, it looks like I need one, so we'll go ahead and put this together. Oops, 7, 8. So 1, 2, 3, 4. We'll put that graph together. So we have, oops, maybe we put those in 2, 4, 6, 8. So we have our completed ordered pairs now. That might help. So you have 1, 2, 0, 4, negative 1, 6, and negative 2, 8. So up top here. So it's a pretty straight line that should actually go through 2, I think. So there's a general description of this line. Now the other way you do this is eliminate the parameter. So what you do is essentially you solve one of the equations for t and then you plug it into the other. So here's our two equations. When you eliminate the parameter, you want an equation y equals some function of x, y in terms of x. So we're going to use this one, y equals, this is what we're going to solve for t. So you solve for t here and you get 1 minus x equals t, right? You could add t to both sides and then subtract x. So we have this value. Now our equation is going to be found. We know what t is. T is simply 1 minus x. So 1 minus x goes in. We substitute it for t. And now we distribute and simplify. So 2 minus 2x plus 2 equals 4 minus 2x. Now that is the equation that matches that graph. Okay, look, y-intercept. There's your y-intercept is 4. There's your y-intercept. Slope is negative 2. So you go down 1, 2, and over 1. And there you go. So that's two ways to do the same thing, by the table or eliminating the parameter. All right, so let's look at our last example. So this one's a little more challenging, okay? Just because it's a trig function, I don't know how much more challenging it is. So when we look at this, we have to know that we can eliminate the variable. So we could start by eliminating the variable, or we could start with a table. Doesn't matter. So I'm going to start with the table here like I did last time. So I have t, and then I've got to be very specific on what my t's are. So then we have x equals cosine t squared. I'm sorry, cosine squared t, and then our y value is sine squared t. You could have x and y now. Now we're going to use specific values. I'm going to use 0, I'm going to use pi over 4, pi over 2, 3 pi over 4, and pi. Now you have to know that this is a periodic function, okay? And so the variables here are going to go in between your x and y are going to go between your x and y are going to be between 0 and 1, okay, periodic function, okay? And so what we're going to do is use these values and get our table. So you're going to plug them in. So when you plug in 0 for cosine, cosine of 0 is 1, and y would be 0. Okay, so our first order pair is 1 comma 0. Now when I plug in pi over 4, the cosine of pi over 4 is going to be 1/2, and so is the sine of 1/2. Okay, so you have half and half. Now you can think about that. How does that work? Okay, well, you plug in, basically, if you look down here, and I wanted cosine of pi over 4 squared, that's what this is, right? And so what I'm going to do is I get cosine of pi over 4 is root 2 over 2, and you square that, and you get 2 over 4, which is 1/2. Okay, so that's how I got that. And I can go ahead and pi over 2, that is going to be 0 for x. Cosine of pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1. So this is 0, 1. So there's our next ordered pair. 3 pi over 4 is going to be actually the same values as we had as pi over 4. Okay, so half and half. And our last value at pi is going to be 1 and 0, right? Cosine of pi is 1. So we have 1 comma 0. Okay, so there's our table of values. Okay, and we can go ahead and graph this. Okay, and so when we do it, well, it should be, here we go. So you can do, we can go out here a little ways. So there's 1, go up here, 1. So we have 1, 0. Okay, we have 0, 1. So I've done that one and that one. Half and half, so it's like right here and here, right? So I've done that one and essentially that one, and I did 0, 1. Okay, and there's our graph, and it's restricted, so it's only going to be here. Okay, so if you have any questions or comments about parametric equations, how to graph them, you can go ahead and type them below, but we'll see you next time.